Today we are going to be looking at logarithms. All right, logarithms are very similar to exponents. They just ask a slightly different question than an exponent does. Before we look at how to change between the forms, let's look at how an exponent and logarithm are similar. So an example of an exponent would be 2 to the third power. And this is equal to something, all right? But the operation here is an exponent. And this is asking a specific question. It's asking, what is the value of 2 multiplied by itself 3 times? Okay, this is what this exponent is asking here. Okay, and that's what an exponent asks. It says the base, it has an exponent. It says, what is the value if you take the base and multiply it by itself the number of times that the exponent tells us to? And we all know that if we multiply 2 by itself 3 times, then we get 8. So when we get 8, what we've done is we've evaluated the exponent. Okay, we found the value, we evaluated the exponent. Now, a logarithm is slightly different. Okay, we can use the same information, 2 to the third power equals 8, but it asks a different question about their relationship. So if I wrote something like log base 2 of 8, I could evaluate this. Okay, I could find the value of this. Logarithms always have a base. In this case, the logarithm has a base of 2, and it also has a number that we're taking a logarithm of. So in this case, I'm taking a logarithm of the number 8. So what do I get when I take the log of the number 8 with a base of 2? Well, this asks a similar question to what the exponent asked, but it's a little bit different. What this says is, what power do I need, or what power do what power do I need to raise 2 to get 8? What power do I need to raise 2 to get 8? Or what exponent do I put on 2 to get 8? Okay, so it's asking this information in a little bit different way. It's asking, what power must I put on a 2 to get 8? And we know from the previous example that that's 3. So the value of log base 2 of 8 is 3, because 2 raised to the third power is 8. Okay, so these all use the same 3 numbers, 2, 3, and 8, 2, 3, and 8, but it's written in a slightly different way because it's asking a different question about their relationship. It's asking a different question about their relationship. Now let's look at how we can convert between the two forms. How can we convert between the two forms? Well, if I look at the two forms, the bases are the same. The base of the exponent and the base of the logarithm are the same. The only difference is the argument, what's affecting the base, which in this case is the 3, and this case is the 8. Those numbers are switched places, the 3 and the 8. And if you look here, log form, the base of the log and the base of the exponent are the same. The only thing that's different are the x and the y, the other side of the equal sign. So let's keep that in mind as we try to go between the two forms. Let's look at these examples. So we're starting in logarithm form, and we're changing to exponent form. The base raised to the answer equals the argument. So if I want to log base 2 of 8 equals 3. There's a really easy way to write this in exponent form without understanding the relationship between the numbers. And that's by putting a base of 2 on both sides. Now a base of 2 for an exponent and a base of 2 for a logarithm cancel each other out. So this would be 8 is equal to 2 to the third power. Or we could write it 2 to the third power is equal to 8. Either way is fine. I'm going to write it this way because I like to have the operation on the left side. I like to have the exponent on the left side. 2 to the third power is equal to 8. Now that's one way to do it. But if we understand the question that the logarithm is asking or is posing to us, then it's very easy to rewrite it as an exponent. So if we look at number 2, log with a base of 4 of 1 over 256 is equal to negative 4. So what this is saying is 4 raised to what power is 1 over 256? And it's 4 raised to the negative 4th power. So 4 raised to the negative 4th power equals 1 over 256. Number 3, log with the base of 1/2 of 16 equals negative 1/4. So this is asking 1/2 raised to what power is 16? Well, 1/2 raised to the negative 4th power is equal to 16. So this is how we go from log form to exponent form. All of these started in log form, they are now in exponent form. What if they are in exponent form and we want to go to log form? Okay, so they're currently in exponent form. Now we want to go to log form. So 4 to the 1/2 power is equal to 2. The 4, it's the base of the exponent, should also be the base of the logarithm. So log base 4, except these numbers should switch, the 1/2 and the 2. So instead of instead of 4 to the 1/2, it's log base 4 of 2 is equal to the 1/2. Now, does this ask the correct question? 4 raised to what power is 2? 4 raised to the 1/2 power is 2. And that's correct. 4 to the 1/2 power is 2. So this one, the base of the log is 5, except now these two should be switched. So 5 raised to what power is 1 over 125? 5 raised to the negative third power is 1 over 125. Number 6, 1/3 to the 0 power equals 1. Okay, so this stays the base of the logarithm, so log with a base of 1/3, except the 0 and the 1 are now going to switch. So this is 1 here and 0 over there. So log base 1/3 of 1 equals 0 means 1/3 to the 0 equals 1. This is correct. This is how we go from exponent form to log form. All right, we just need to switch the question. We just need to make sure the question is asking the right thing. Now, what if we want to actually find the value of a logarithm? Like, for instance, all of the previous problems, they gave us the value. They said log of this is equal to this. At number 7, it says log base 4 of 16, but it doesn't tell us what it's equal to. It's our job to figure out what it is equal to. So it's a three-step process. The first thing we do is set the expression equal to x. Then we change it to exponent form. So 4 to the what power is 16, 4 to the x power is 16. Now you may be able to solve it at this point, but I'm actually going to use the properties of exponents to solve this. So that means solving this by giving them the same base. So 4 and 16 will have a base of 4. So this is 4 to the x, and 16 is 4 to the second. Once the bases are the same, both have a base of 4, we can now set the exponents equal to each other. X is equal to 2. So what this means is that log base 4 of 16 is equal to 2. That's the value of this logarithm. And the question that this number answers is 4 raised to what power is 16? 4 raised to the second power is 16. Number 8, log with a base of 81 of 9. So first we set it equal to x. Next we change it to exponential form. So 81 is the base raised to the x power is equal to 9. All right, now we solve this by making the bases the same. Well, in this case, I would have a base of 9 for both sides. So 81, that's 9 to the second power to the x, and 9, that's 9 to the first power. Multiply these exponents, so I have 9 to the 2x equals 9 to the 1. Now the bases are the same. Base of 9, base of 9. I can set the exponents equal to each other, 2x and 1. Let me do that up here. I'm running out of room. So I'll set those exponents equal to each other. 2x is equal to 1. Divide by 2, and we get x is equal to 1 over 2, or 1/2. So let's go back here. Log base 81 of 9. That is actually equal to 1/2. That's the value of this logarithm. It's 1/2. Okay, number 9, log with a base of 1 over 8 equals 512. Set this equal to x. Change it to exponent form, so the base of the logarithm is the base of the exponent, but these numbers should switch. So x 512. Right. So I'm thinking a base of 8 will work for both of these. I know that it works for the left side. I've just got to check to make sure it works for the right side. So I need to see, can I get 512 by multiplying 8 together a couple of times? And yeah, I can do it by multiplying 8 together 3 times. So 1 over 8, that's 8 to the negative first power. And 512, that's 8 to the third power. So I got to multiply negative 1 and x, so that's 8 to the negative x equals 8 to the third. Now the bases are the same, they're both 8. I can set the exponents equal to each other, negative x and 3. So negative x is equal to 3. Solve this for x, divide by negative 1. x is equal to negative 3. So let's go back here. Log with the base of 1 over 8 of 512 is equal to negative 3. And then number 10, log with a base of 32 of 1/2 equals x. Change this to exponential form, so the base of the logarithm becomes the base of the exponent, but these two numbers switch. So x and 1/2. So 32 to the x power equals 1/2. I'm going to use a base of 2 for both of these. All right, let me see. I think it's 2 to the 5th power for 32. 3, 4, 5. Yeah. So this is 2 to the 5th power. And 1/2 would be 2 to the negative 1 power. So this is 2 to the 5x equals 2 to the negative 1. The bases are now the same. I just need to set the exponents equal, negative 1 and 5x. So I got 5x is equal to negative 1, divide by 5. X is equal to negative 1 over 5. And that's the value of this logarithm. So log base 32 of 1/2 is equal to negative 1 over 5. All right, so homework is on page 95, numbers 1 through 14.